Hello everyone. I wanted to talk today about the accelerometer testing with Klipper. And this is just a update video kind of about the state of affairs. Again, these features are in development. They're changing, so there's not really a way to give you a good guide because the guide would have to be rewritten every few days or every week. But I wanted to give you an update because previously you had to go to Dimitri's fork of the Klipper repo, and you had to go to a very specific branch, and there were certain things you could not do with that branch. Kevin has started to implement the ADXL345 sensor for Klipper, which means that it's a lot easier now to test this out. Where before I mentioned sometimes you needed 2 Raspberry Pis to get the accelerometer data and move the toolhead at the same time. Now you can do all that from the same single essential Raspberry Pi. So it's getting a lot simpler. So I just wanted to kind of give you an overview of what's changed and what things we are working on and what things you can expect in the future. We're going to talk about Klipper because I know I've talked about Klipper and accelerometers and input shaper before, but what's cool now is that the accelerometer support is it's not merged into the master branch of Klipper yet, but it's getting there. And what's exciting is this enables you to do a lot of cool things. How you install it is this: you essentially, it's not this master branch, but it's this work branch right now. Obviously, all this is subject to change in the future because it is in development. Kevin is working on that with Dimitri. If you follow this guide here, note it is on this branch, it's under documentation measured resonances. It'll teach you how to install the accelerometer, the things you need to send, the commands, how to set it up to be read by your Raspberry Pi and Klipper. And then you can do all these tests that I'm doing now on your printer, which is great. There's a few really cool things here. One is this test vibrations command generally takes about 20 minutes to do it. If you're doing 10 to 100 hertz at half a hertz steps, at least on my printer, it takes 20 minutes. So if you're doing X, Y, and then A and B, which A and B is the diagonal directions for core X, Y, so essentially the A motor or the B motor, that ends up taking close to 80 minutes to run. And if you have to babysit your printer and every 20 minutes enter a command, it is really hard to get that done. It just takes forever because it's hard to get anything done. So with this new version of Klipper, these queue up correctly, so you can write a macro. So I'm going to hop over to my GitHub here, and I've created this documentation repo. There's some interesting data here. I try to push up data, my raw data files, so you can look through them. It's not super organized, but if you're curious, you can go through it. But in this vibration data file, I actually have some macros that I've started working on, and the community has helped me out too with. And again, the documentation is not great, but these 2 macros here, this resonance test, essentially finds the center of your printer based on your Klipper configuration sections from your stepper X and stepper Y. It finds the center of that and then uses those for, in this case, X and Y, and then B and A. So you get all 4 tests done with one command. So you can send that command, let it do its thing, and come back in an hour and a half and have all the data. So that's really great. The other thing that's really cool is that once you get these and look through the X and Y data and find your resonances and enter them and restart your Klipper so it pulls those values in, we also have another macro called vibration test that is also in development. But what's cool is you'll see here it homes, and then essentially it'll do a move in X, Y, and then diagonal A and B directions. And it will start up, move a short distance, and then stop. And it is recording, you'll see here, accelerometer measured chip. So this is recording data from your accelerometer during this move. So you see it ramping up, it running at constant speed, and slowing down and stopping. And then after it stops, you can see how long it takes for that kind of ripple or a vibration to die out. This test only takes maybe 60 seconds if you're generous, maybe 20 or 30 seconds otherwise, to run. So you get all this data with 8 files. you get X, Y, A, and B with input shaper enabled with your parameters you just entered, as well as without. And so you can kind of compare those differences and see for your printer with your accelerometer and your data how much of an impact it has. So if we go back once at the bottom here, again, this is Excel. It is this plot is from Excel. We are working on using, and again, it's not my strong suit, so some other people are helping out, but getting this in a Python script, so you can essentially just run the test and then have it generate all the plots, so you can just look at the images, so it's a lot easier for you. But I did this in Excel, and you can see this orange line here is the stock Klipper without input shaper. You see as it moves and stops, in this case this is right as it stops, it oscillates a lot, and it takes maybe 1/10 of a second for it to really die down to fairly stable values. If you look at the blue line with input shaper, exact same move, but it just really has this initial hump, which is going to happen because you're stopping, so it's always going to have to accelerate or decelerate. But then it just largely doesn't have any oscillations after that. So that's really interesting. Same thing with Y. We have a lot of oscillations, and these oscillations actually go on for quite a bit. You know, they're not super severe, you know, later on, but you know, they last a good 0.2, 0.3 seconds or so. With input shaper, it dies out really quickly. So that's really cool. So again, you can test these scripts and see what happens. The one thing to note is that after you run input shaper and after you enter those parameters, you want to make sure you want to run the ring test print with input shaper enabled, and do the same the same tuning tower command that increases your acceleration from 0 to 7,000 automatically. And you want to see there's a feature on that print where essentially the lines come in and does a little jut around and then comes back, so it's a very small gap, and you want that gap to not essentially be too rounded. Input shaper at really high accelerations can kind of round off some sharp edges, and so you just want to make sure you don't do that, run too high acceleration, otherwise you'll lose some features that may be important on the part you're designing or the part you're printing. So that's a good follow-up there. So this is really exciting. Essentially we're building the both sides of the test setup. So we have, here's the tensions, here's how we're going to measure absolute values on tensions for the gate belts, and then we have a test procedure that is applicable to a large variety of Core XY printers, and so everyone can get the data and plot it and see it. Because honestly, this kind of test is only so interesting if I'm the only person doing it. But if you are doing it, and if it's easy for you to pick up, run the test, get the data, and then we can kind of gather all that data together, that's really where it starts getting interesting to see how your printer works, and kind of what the ideal settings are across the board. And also, if you have a lot of data points like that, you can start seeing where someone may have their belt tension too high or too low. Or another interesting thing with the A and B, the diagonal test, you get a component of the X resonance and the Y resonance in both. And so theoretically, at least in a Voron printer with a Core XY setup, they should be identical. And if they're not, you can kind of point to either uneven belt tension, or maybe there's something loose in the gantry that's vibrating or wobbling when one belt is running, when one motor is moving the tool head diagonally versus the other. And so you can start to isolate a lot of really cool kind of potential issues with your assembly, and kind of hunt those down and see the immediate kind of impacts of those that are really hard to do by just looking at a test print and saying, oh yes, the screw in your XY joint is loose, which you couldn't do otherwise. But now you can at least point to certain things to look at. So all this is really exciting. Again, this video is probably really long, but I just wanted to get this out there so you can hear and see what you think about it. So again, let me know if you have any questions. I hope you have a good one. Bye.